And we're back on an introduction to the ThingWorx and Azure Industrial IoT integration using OPC UA. Now, this is a part of a three-part series, this being the second part, where we're actually going to dive into the overview of the architecture and taking a walk through some of the components. Now, it is somewhat of a complex architecture, so this is probably going to be a relatively long video. Also, as the objective is to essentially cover some of the things that are not covered in the documentation from Microsoft and from PTC on setting this up. So in the first part of the video, we basically discussed a little bit about this architecture. And I guess this is as good as time as any to talk about some more aspects of this. The biggest part of the setup of this overall architecture is the Azure Industrial IoT application that's essentially a microservices applications that are running in Azure Kubernetes service. Here, this is somewhat of a simplified view of it, with the key main features here being the OPC Publisher, Twin, and Discovery. And these have different application endpoints or REST API services that are going to be orchestrating all of the overall function of this industrial IoT application, as well as doing the command and control of those modules that are running down in the IoT Edge. So it's important that we get these things wired up. There's a lot of stuff that happens automatically here, which is really nice. But there are some things that that we do deploy using scripts and with Helm charts. And so for that reason, it's important that we understand really kind of how this works and how it comes together, where we should be looking for logs, where we should be, and how we should be verifying that everything is working properly in order to ensure that we're going to be able to have proper information flow from our OPC UA service all the way up the stack into ThingWorx. Okay, so I think the best way to talk about this intuitively is just kind of from the bottom up. This is also how I set it up, really just kind of focusing on, let's start with Kepware, IoT Edge. Actually, I didn't actually do it this way because we need to have everything wired up. But we will go through IoT Edge next, knowing that I've already got this running. We'll have a look at IoT Edge and then come up to the Azure side of the cloud over to the Hub connector into ThingWorx. Okay, so first of all, in Kepware, by default, the OPC UA server endpoint is not activated outside of the local host. Obviously, this is for security reasons. So the first thing we need to do is make sure that we come in here and we select the second endpoint. It might not be listed, so we might have to go in and add the endpoint. But if it is listed and it's just not enabled, then do enable that. And I can double click on that, and here's all the settings. And the default settings also for security obviously are basic 256 SHA-256 to sign and encrypt, and the port 49320. This can obviously be changed if we want, but there's no need for me to change it. So I'm just going to leave the defaults. Another thing to mention here is while we're in here is the trusted clients. These are client certificates that are passed to the OPC UA server Kepware, and essentially they're rejected by default. We're going to leave this like this is for the time being, with all these certificates being listed in there as being rejected. But this means that we will not be able to establish a both client and server trusted connection until we have approved those certificates. Okay, so I did just activate the endpoint there, and we made sure the security is set up. There is one more thing that needs to be done in the configuration over here in project. If we go to properties and then OPC UA, allow anonymous login is set to no by default. Now, we don't need to have this enabled, but if we leave it set to no, then this means we need to create a user that's going to have the appropriate permissions in the overall Kepware project and channels and devices, which I haven't set up, and frankly, I don't need to. So I'm just going to leave this. I'm going to change this to anonymous login to yes, and this just means that in all the connection to Kep server, we won't need a user and password. We will just use the certificates used to authenticate the channel as well as encrypt it. Okay, so now those few changes have been made. I need to reinitialize the runtime engine, and that's doing that. And if I come over here now, this is a program, great little program called TCP view, which is kind of doing essentially it's a running netstat in the background. And frankly, what I do is I turn this, click on this A up here, and this is just going to show that the addresses and the ports are not resolved to names. And then we can come in here and we can just sort by this local port column, and I can quickly have a look down. We're looking for 49320, and let's make sure that Kepware is listening on that port. So here we see that we do have a port open 49320 bound to the localhost, and we've also got this one bound to 0000. So we should be able to accept connections from outside. So let's just do a quick test here. First of all, I want to make sure that I can talk OPC UA. Now this is going to be local, so it's not the greatest test here, but we'll do the job. And I can come in here and just basically, this is my host name, OPC UA TKS. So we're going to click on that, and 49320. And here, if I click this before connecting, it's going to give me all the options, but I'm actually just going to click connect because this process client is going to essentially negotiate the server capabilities. And here it's saying that the only thing we can do is sign and encrypt. So do you want to do that? Yes. Okay. Now it's going to exchange the certificate between the two. And it said, error occurred verifying security. Bad security checks. So this is the same sort of thing that is going to happen, whether it be a client that's on this machine or on another machine. So we really need to make sure that those certificates are being exchanged appropriately and that are validated. So previously we saw this was already in the list, but if it hadn't been in the list, it would now show up in the list, and I can come in here and I can say trust. I'm going to take the opportunity to trust all these other um, Azure ones as well here. So we don't have to come back in here later, and close that. Okay, so now let's try to reconnect. Okay, so reconnection, this works. We're connected to the server. We can see data, take my word for it. We got a check mark. And we also even saw in the TCP view that we just got this established connection from this particular IP, and we can even monitor the traffic that's going across there. So that's perfect. I do want to just make sure that I can communicate with the Kepware OPC UA port from outside. And specifically from outside, I mean, not really from outside, but from this thing right here, which is my Azure IoT Edge. And this is running on a Linux Ubuntu server. It's on the same virtual network. So if I do a ping, we can ping the TKS, ThingWorx Kepware server machine. You see that's coming back just fine. And so now really the test is I want to be able to verify that that port is open and I can communicate with OPC UA from here. So there's a neat trick to do that, and it's the command called Netcat. And Netcat can essentially do all sorts of things like TCP, UDP. So we're going to use the Netcat command to essentially do a test on the OPC UA EVA TKS machine to the port 49320. We're going to see what happens. So normally this shouldn't take so long. So there is a problem. And the problem is if somebody doesn't answer the port, it's either the port is not open, it's not bound, which we already checked, and it certainly is bound. So this means that it's a firewall problem. Somebody else is blocking it. So let's come back into our Windows machine here and have a look at firewall configuration. And advanced settings. So I'm going to create a allow rule, an inbound allow rule for this OPC UA traffic. And so I'm just going to say new rule over here. I'm going to say based on port because I know exactly what port it's listening on. And TCP, so it is only the TCP protocol. It's 49320. Allow the connection. Definitely allow the connection. That's what I want. Okay, so here I have three options. This can be a bit of a trap, so watch out for this. This is, the different Windows firewall rules, whether it's a computer that's on the same domain as yourself, whether it's a private network or a public network. Private network might be around you or might be one that you have trusted, and public network is one from outside of the network that you're on, like the internet, but not necessarily the internet. So I'm going to uncheck public because you shouldn't need public. Just be cautious that you have the appropriate privileges and that your IoT Edge is going to be found on this private network, because otherwise the rule won't work. And we're just going to call this ThingWorx Kepware Server OPC UA. Okay, that does the trick. And the rule's created, and we can see that it's activated by default. So let's go back over to our IoT Edge machine and try that Netcat again. Okay, there we go right away. So we got a success, able to connect to the port, able to get in there, and we're all good. So we can leave that other machine alone now. Our Kepler machine is just fine. Let's have a look at this one that we're on here, which is the IoT Edge. So I've obviously followed the documentation for all of this stuff, wherever it went. Over here, you've got the GitHub pages for Azure Industrial IoT. You've obviously got the online help for Azure IoT Edge, and I've just followed the IoT Edge installation instructions in order to get this IoT Edge running on Ubuntu. And I'm going to start it up. Before I start it up, let's have a look at the configuration. The configuration is nothing really to see in the configuration, just the primary connection string. It's one value that you need to put in there in order for it to connect up. And so let's start the service. Okay, so we're starting up the IoT Edge. It's going to take a second to get started. Okay, so let's use the Docker command, sudo docker ps. And docker ps is going to give us a list of all the Docker containers that are running in the Moby engine here on our IoT Edge. And basically we see that we have 5 of them: Discovery, Publisher, Twin, Edge Hub, and Edge Agent. Edge Agent is the runtime agent for the IoT Hub. The Discovery, Publisher, and Twin are what are used for the OPC UA functionality in the Azure Industrial IoT on the Edge side, right? Those are those ones that we saw back over here, OPC Publisher, Twin, Discovery. And they are what are communicating with the command and control aspects over here, right? So the Edge Agent and the Edge Hub are essentially, the Edge Agent is talking up to the IoT hub, and the Edge Hub is essentially an edge version of the hub where incoming communications and endpoints and brokering can be done. So if we come back over here, just have a look at this. So it says up about a minute. So this thing is coming up. This is good. And let's just do something. So sudo docker logs. And we're going to have a look at these 3 things: the twin, docker logs twin, and we can see here at the bottom that it says module host is started. Now, if we come back a little bit, these logs for these containers are really useful, essential for diagnosing what can potentially be going on. Here we do see some things like endpoint does not support the user identity type provided, retry error to unauthorized. These messages were because I had changed the endpoint configuration in the Kepware that we just did together. And this is what is coming up in the IoT Edge. So just be really conscious that the types of things that are going to happen between the communications in IoT Edge and your OPC UA server, whether they be a trust issue with the certificates, an inability to connect, potentially an inability to communicate with the server, they're all going to be found in these 5 containers. So between the Twin publisher is used for making the subscriptions to the tags, getting them from the OPC UA server and pushing them upwards. And then discovery, for discovering the endpoint and registering the application. And Edge agent for communicating up with the IoT hub. So everything's looking okay here, Edge hub. Okay, and in the Edge agent and Edge hub, you'll also see things like the provisioning of the rest of the modules. Everything looks fine here, so let's move on to the cloud side. And I guess it's a good opportunity to just touch briefly on this. So this is obviously the industrial IoT application architecture by Azure. This is obviously the source code repository. There's a lot of good documentation in here, issue tracker, all sorts of things. Definitely come in here and look for how to deploy all this stuff, look for help on things. I've obviously got it all running already. So let's just kind of look at how this looks. So first of all, these are essentially the resources that are provisioned using the deploy scripts and setting everything up. All of this has been deployed using the scripts automatically, and basically it's intertwined operations between these things. This IoT hub is if I look in here, this is what has that IoT gateway device that we were just looking at, OPC UA EVA IoT Edge. And normally we should see that it's 200, it is responding okay, and that we have these 5 modules that we just looked at in the Docker PS. We saw those modules and they're communicating okay. And those were deployed using essentially if we come and look at the deployments, we see that there's a configuration type layered deployment, and that layered deployment is coming from the fact that we have this in the device twin. In the documentation, essentially it says to add this tags section here, and this tag section is adding this here of this type IIoT Edge of type Linux. Okay, so this is essentially flagging this IoT Edge device as a Linux IIoT Edge. And if we come back to here in the IoT Edge, we see this tab IoT Edge deployments. And here this is showing us these layered deployments, the IoT Edge layered deployment. And if I come in here and have a look at what this looks like, we see that there's a target conditions to see if that target condition is matched. Then we're actually going to do a number of different things. Edge agent, we're going to make sure the edge agent are published. There's things like routing, and then this is really the deployment manifest. This is what is including all the details about the particular deployment. And then the same is essentially going to deploy those for the discoverer, the OPC publisher, and the OPC twin. So that is that's essentially how between those two things, once you get your IoT Edge created and connected using the primary connection string, and you change the device twin to add those tags, then the rest of the deployment happens automatically. So that's what I was referring to about this being very simple. And then if we kind of come and look in here, let's kind of unpack this a little bit. We do have obviously the IoT hub that's receiving the telemetry and managing the communications and the security of the certificates and everything. We've also got this AKS cluster, and if we come over into the AKS cluster, it's within this AKS cluster where we're running these this application, right? So AKS clusters running these things. There's some other services obviously that are leveraged for storing securely things and doing a key value pair storing for the data on the twin. And so this AKS cluster has essentially one node pool that's created. And I have essentially taken one node to keep the cost down. just note that during the deployment, you need to make sure that your Nginx ingress, everything is only going to deploy one replica. Otherwise, you need more than one node. Um, and if we come and have a look in here, one of the things that I found quite handy is that I did notice that it deploys these container insights, and I've been using them just to be able to track and monitor the status of the overall application deployment. And here you can see that everything that's deployed here is active. If we come into workloads, we do see the different workloads that are deployed here. Now in the documentation, they're not really going to talk to you about the portal and all this stuff. They're going to talk to you about using kube control. And we can obviously do this sort of thing with kube control in here, but just from a portal perspective, thinking that you've got this set up and running, this is a really easy way, especially if you're remote. You might not be able to always to SSH into the machine that you use to set this up, and you have kube control running. So I found that this is very helpful in diagnosing and troubleshooting things. Also, because of you can see the same type of information here, like on the services, the external IP that's bound that we created in the installation process that's bound here to the load balancer Nginx, and this, we can even go deeper into this using the container insights, and you can see here we do have cluster metrics on the AKS cluster, but we can even look down into the containers themselves and the deployments just to have a look at, does everything look to be running okay? What's the overall resource usage? And where I'm really going with this is we want to have a look at some of the other things. So if you do see any X's on any of these things or warnings, the industrial IoT telemetry CDM processor container, for example, is going to be required for telemetry data. So because of the fact that container insights is set up and I've got this pointing to a log analytics workspace, I can come in here and yeah, essentially do a query on error messages from this particular pod. And this is, as I say, just really helpful for troubleshooting things. We can look back through time. Obviously, if you want to write some different queries, you can. But here is just an example. If we see that we have an issue on something, we can come in here, we can have a look at some of the information and see if it'll help us understand what's going on. Frankly, once I got all this application up and running fine, then I haven't had any issues with it since. But the green checks are obviously required. If you don't have all green checks, then this is going to break down. It's not going to work. So this is a good spot to ensure that you do have things running. I will also mention one of the things that I saw, crash loop backoffs are causing a lot of restarts on the pods. And so they're building up a lot of space in the analytics workspace. So if you are having issues and you can't get this working, just make sure you do an uninstall of your deployment before you just decide to leave it for weeks, because you will have enormous buildup in the log analytics as AKS is trying to orchestrate the restarting of these 20 or 30 pods every few seconds for a couple of weeks. Right. So the one thing I did also want to mention here is if we come back over to the talking about AKS here, there's a step in here where we actually have to create our own public IP address, and that was something that got me a little hung up here in all of this, because it wasn't clear enough, I guess, for me that this needs to be of standard type, because it's only the standard type that can be used with AKS in order to bind the Nginx controller. And once you have been able to deploy the Nginx controller, you see that the standard type SKU public IP does get bound and associated to the Kubernetes cluster. And that's essential for what we just saw to be working in order for it to get an external IP address. And I will just mention that this external IP address, or this DNS name, is now the DNS name of the overall Azure Industrial IoT application. So when we come back to this slide, when we refer to this from now on, it is that address that we just saw here. There's some confusion about that in the overall documentation, but the other IP address that's used for AKS is an API for controlling and working with AKS, but it's not for accessing the application. And that's really one of those steps is we get the Nginx controller in order to distribute the requests. It's essentially our proxy server on the AKS. And so that IP address is really important. It needs to be used everywhere within ThingWorx, within Postman, etc. And that's obviously over here on the MC. The MC is the infrastructure aspect of the Kubernetes cluster. Okay, so I think that's pretty good on that side. This is probably a good opportunity to come over and have a look at the Postman setup. So getting things working here as we're kind of working up the architecture, and you do have all this running in IoT Hub, and this is connected and possible to communicate. We're looking at setting this up with ThingWorx, but it is also possible to set this up with Postman. I highly recommend this. Frankly, I had a little bit of a difficulty with the app registrations and the OAuth token with Postman, but if we just kind of have a quick look at the app registrations over here, owned applications, so there's this OPC UA, EVA client, and EVA web here, and I believe it's in the EVA web. No, maybe it was in the other one. It's obviously important. So here's those DNS entries that we were talking about. I guess it's in the client authentication, right? So it's in here, client authentication. This was the callback URI redirect that's going to be used by Postman to do the OAuth 2 lookup. Okay, so that's important. We need to have that in our minds. There is a typo somewhere in some of the documentation with a point. It doesn't really matter. It just needs to be the same as what we have in Postman. And then obviously the client certificates and secrets. We need to have a Postman secret, the setup here. And if we come over to Postman now, and we've got this OPC twin environment that's created. Obviously follow the Microsoft documentation on how to set this up, but let's just have a quick look at the setup for the authorization. So here we have OAuth 2 authorization, and essentially, here's the settings to get the new tokens. As I just mentioned, this is that callback URL for the OAuth 2 authorization that's using that public IP address or DNS, as well as that service URI redirect. And then, in here we have things like, off the top of my head, I can't remember, but there's a subscription ID, there's a tenant ID, and then there's the overall application ID, which is in the Azure app registration. So important to have all this stuff set up appropriately. And once you do, you know what, I guess I should get a token. Once you do, it should, right, allow you to sign in. Give you a token like this. Here's my access token. Use token, update. Okay, so now I've updated the token in my collection, and I should be able now to essentially do something like get applications. And there's nothing, right? So I did get a response here. There's no items. Status is 200. Okay. So we'll come back to Postman, but this collection that's provided by Microsoft is really valuable because it enables you to test everything is working, not only validate it, but to eliminate and to remove the questions of the other steps in the process, right? To know if you have an Azure IoT Hub connector problem while you're getting this configured, or if it's a ThingWorx issue. When we have Postman that's set up here, really, we're eliminating these two components here, and we know that we can be getting data flowing from here. Okay, so now let's take the opportunity and come back over to ThingWorx. So in ThingWorx, I've obviously, I guess, no, ahead of myself here, not ThingWorx, Azure IoT Hub Connector. So Azure IoT Hub Connector is running here on a Linux machine. And if we have a look at the overall configuration file, really the same principles as the V3 connector. There's a few new options that exist in the V4 connector, but really the main thing is this OPC UA section right here. A little bit bigger. This OPC UA, and what this is doing when we put this OPC UA enabled equals true, this is going to turn on the translation between the OPC UA messages that are coming in and the thing model. Okay, so this is what's adding that intelligence, that transcoding, if you will, that was not previously there. So that's very interesting, but I will say to make sure that you keep this to false initially, because you will get errors and you won't have your IoT Hub connector connect properly if not everything is working properly. So what I did was I made sure that this was set to false. I made sure everything was connected. I made sure everything that was working. Where did our little diagram go? Here, because this path is still there. And then I focused on making sure that I had all the OPC UA settings set up there afterwards. I don't think we really need to say anything more about this. Let's get out of there. And let's put the logging back on. Okay, so I guess one thing to mention in the logs here, there are some quite lengthy logs that kind of get in the way. And this is because of the fact that it's showing us logs on those IoT edges that we're adding. And because we don't need to have a ThingWorx device for those IoT edges, it'll show up in here. So what I just did was I just imported the IoT devices on the connection services hub thing, not the template. There's a service in here, IoT import. Just gonna import, right? Import Azure IoT devices. I'm just going to run this on everything. So this is a regular regex on Azure IoT thing template. So it's going to import Azure IoT things for any devices that I have on my IoT hub that haven't been imported yet. So I don't really know what's there, but if I go and have a look in things, okay, so there's the new gateway that I had provisioned, and now it's got an entity in. Actually, this one is yeah, we don't really want that one imported into here. So that's good. That'll get out of our way. And now let's come over to the configuration aspect of this Azure IoT Hub. So I'm not going to go through the previous configuration steps of this. It's obviously quite well documented, and there's a lot of people that are familiar with getting this set up in the V3 and before. So, these are really the aspects of, the consumer group, making sure you have an appropriate consumer group that is set up for ThingWorx to be able to listen and consume on, and that's set up in also in the IoT Hub and everything that's set up here. And then when we get to this part, the OPC UA, Azure OPC UA stuff, these are the specific configurations for the V4 connector that are implementing the OPC UA functionalities, right? So when we talked about that DNS name, this is that DNS name, right? This what we're calling the base URL here, and essentially, all the details, the subscription ID, the tenant ID, twin path, these are the details that are going to be used to establish the API calls to that to the application in the cloud on this channel here, right? This is what we're setting up right now, is this command and control channel. Um, right, and once we've got that set up, at this point, I would go back into my connector over here, change that from false to true, restart my connector, and if all goes well, then you should see your connector come back online, and everything should be okay. Um, as you may have seen there, I was also monitoring here in the top. This is just the ThingWorx application log, and this is the connector log. So this way, I like to look at it this way because you can see the things happening simultaneously in time. And when you restart the connector or something comes in, then you see the impact that it has in the IoT Hub connector as well as on the platform without having to look through the logs in ThingWorx. Okay, so that's good. We got all those settings set up. What's next? So in the last video, I did have a look at this mashup. This mashup is obviously pointing to the configuration that's calling those REST API services in the Azure Industrial IoT application in the cloud. But we're going to talk about this a little bit more. So first of all, I'm going to go back. We're going to add a new application. We're going to get that registered. So I need to come back to my Kepware. Actually, I can just type it in. Okay, so we did all our due diligence. The port's open, everything's listening. We're gonna add that application. Normally at this point, it's already been found by the IoT Edge discovery module, and so adding that is, the application knows exactly which IoT Edge to pass this off to, and it should add this application and create an endpoint for us to communicate. And it has done that. There's our application, and here's our endpoint that we see is in a deactivated, disconnected state. And this mashup is used. If by clicking that, I can activate the endpoint. But at this point, I'm actually going to use the opportunity to talk to you a little bit about Postman. So here, if I come back over to Postman and I get applications again, now I'm going to see that application is registered here. It's TKS, OPC UA. So I got the information about that OPC UA server, as well as the endpoint should be in here somewhere. And activate endpoint. So I want to do the browse endpoints. That's the one I was looking for. So it did create the endpoints, and I do have this. So here it's saying, okay, we've got this one right here. Basically, I want to copy this endpoint. I'm going to go activate that endpoint. But first of all, browse endpoints. In the browse endpoints, I see that this is deactivated and disconnected. Just so that this is clear, these services are the exact same thing that ThingWorx is doing here. We've just implemented these in ThingWorx so that it's a lot easier for people to use, and they don't need to set up the connection in Postman and all these things. The intent is really to leverage the applications that Microsoft has built. But I just really want to show you that we're talking about the same thing. So some of the things can be done in either way, right? We can also anticipate coding this if we wanted to. So get endpoint. I want to activate the endpoint. And so up here, I'm just going to paste the endpoint / activate. And I believe there's also deactivate command. These can obviously be found using just browsing through the Swagger endpoint on the API. And we got a status 200 OK with one response. So this is good and bad. One of the things that I did struggle with to know that this activation request has gone through now, but we don't actually know that it worked. Because of the fact that it's going through the application and it's trying to make this become a publishing an active OPC UA server endpoint. So if for whatever reason it doesn't work, and obviously it has here, when I refresh, I'm getting activated and connected and connection state is ready. And I should get that same thing here, browse endpoints, all endpoints. I'm going to see that here, activated and connected, ready. But if for whatever reason that's not working, then getting that one status 200 okay is not very helpful. And I did see that on a number of occasions. Some of the reasons can be, at this point, you can't activate the endpoint if you have a certificate issue. So at this point, you should really be coming back into to Kepware OPC UA configuration over here, verify that you have the trusted client certificates here, that everything is okay, and that you don't have any rejected certificates. There's some other reasons why that can be disconnected. Make sure obviously your firewall ports are open. IoT Edge is turned on, connected, enabled. But in any case, we've gotten that happening. The activate request has happened. So let's move on. At this point, we are going to have an auto-generated UAT 96466 device that's created in ThingWorx, and we're going to be able to find that under monitoring remote things. And this is in relation to the IoT application there. So here we have it. We can also go and browse through industrial connections over here, and we'll see that same thing. We see that it's not persisted yet. We need to persist it. And to do so, just come in and click save. Because this is a little bit of a cryptic code used by the Azure IoT application, obviously a good practice to put some project tags on here, maybe some other model tags, as well as a description. I'm just going to put my server name in here, as well as just what it is, really, so that if someone else is coming in here to look to figure out what's going on, these things are clear for me, but might not be for everyone. And right, so now let's come on over to the discovery. We can do some tag bindings, and we already did this in the last video, so I'm hesitating doing it again. But I think what we will look at instead is just this notion of push on change, which frankly I quite like, certainly in some form of optimal approach for this. We are going to come across a bit of an issue here at some point. So we'll just take a Boolean. You know what? I'm gonna take all these Boolean values. Okay, so let's come in here, change the names of these. Set the scan rate to 250 milliseconds and push threshold to 1. Okay, so now we've got 4 tags that are set up for this new thing that we're about to save. Before we save it, we're going to come back over to Postman. And let's have a look. So we do have the endpoints set up here. Hopefully I've still got, all right, so this is what I want. So I want the twin get currently published nodes. And you can see in here that I've got this is the endpoint ID. So the currently published nodes are essentially, the nodes are my tags that are publishing, and you can see that I don't have any. So when I come back over to ThingWorx and I click save, it's going to make those requests that are going to go all the way down the ladder. This is the command and control channel. It's going to save them in Cosmos DB. It's going to use the OPC publisher module to essentially go and configure this publisher so that it's going to subscribe to those tags changing. So we should have a 250 millisecond scan. Update frequency is a better way of saying that. Update frequency over here, and then they only should get pushed up to Azure IoT Hub when they change by 1. So save, unknown state. Ideally, they should come in okay. Okay, Boolean thing is connected. There we go. Okay, so we've changed from unknown quality. It took us a second. We get good quality coming in. So this is the quality parameter, obviously coming from the OPC UA data. And let's come back over here into Postman. And now when I redo this get currently published nodes in Postman, we see that there's 4 node IDs that are published. And this is the syntax of the devices that we saw in there. And so these node IDs are essentially, the full OPC UA tag name. And we see the publishing interval as well as the sampling interval. So I guess what's kind of interesting is that we don't see anything about the on change frequency here. So we'll see how this actually behaves if we're getting these values when they only change, like we should be, or not. We might have just stumbled onto something that is not ideal, not intended in any case. Okay, so those should be publishing, and let's come into VS Code here, and I'm going to refresh this Azure IoT Hub over here, and good opportunity to talk about some of these things here. We see that we've got now 3 devices online: the OPC UA IoT Edge, and then this UAT, which is obviously our endpoint ID that's been registered by the application, and then this dataset writer. The bottom one, the UAT, if we come over to the IoT Hub and down into IoT devices, we see that essentially the application, the Azure Industrial IoT application, has created the application endpoint as an IoT device, as well as this endpoint for the OPC UA server, which is also an IoT device. So this is how it's using those in IoT Hub, and then this dataset writer, as I've understood things, is used for the publishing endpoints, the publishing nodes. Let's come back over here, and so the 3 of those are online. That's obviously good and required for us to be publishing data. And let's start monitoring the built-in endpoint. See what kind of data we have coming in. So this is a good opportunity to just talk about one thing. The default configuration for the IoT Edge is meant to be optimal balance between the message sizes for IoT Hub, as well as latency, as far as when am I going to find out something has changed. And so we're not going to get updates every time that there's a tag change, but they're going into this buffer, and this notion of batch telemetry. You can search for it and find out the default configuration. It can be grown or shrunk, but basically it's looking for 50 tag updates or a 10-second interval before it essentially sends the telemetry messages that have been batched up into the cloud. So um, Okay, so we'll turn this back on. Okay, there we go. So we're using the default consumer group. We've got the monitoring going and we don't see anything. So frankly, that's a good thing. We didn't really want to see anything just yet. Um, let's come over here and have a look at the OPC Quick Client. And let's write a value in there. So we wrote our first value. What do we got here? Publisher, IoT Edge publisher message. Okay, so that's a standard publisher message, module messages. Now, and as I mentioned, it's going to require us to get some changes going on here because of the fact that this batch telemetry is essentially storing these things up. So this doesn't really help us too much about how quickly we wanted to be getting these updates. But knowing that we are, if we look in here, we should be able to see, yeah, we do see server runtime has this channel. We've got this constant data that's being essentially received from the IoT hub as we expect for frequent scans, but they're just not being sent just yet because they haven't changed enough. So to kind of get around this, let's go back to ThingWorx, check if we've gotten any updates yet, and we haven't. And obviously this is because, frankly, there's not a whole lot of messages. I've only changed 3 things. So there's 3 messages to send up. Let's add some other values in here and fill it up. You know what I'm going to do is just cancel that, change one of these values, maybe the Boolean 4, and we'll say push threshold is always, and then save that. Okay, so now we see that those first 3 did come through with that change. It really quickly filled up the buffering and it sent those update messages through for us. So let's come back to here. We obviously have those things there. And if I write a 1 in here, so that's the only tag that should be filling that up. And however, we don't see those updates coming in. So let's put that threshold back to 1. Okay, so it has come in. Anyways, I think we've done a good number. I understand this was a bit of a long overview, but really the intention here is for those adventurous folks out there who are looking to get this set up themselves and to try and provide some help and some insights into looking at the various aspects. So I hope this has been beneficial for you, and if it has, please do leave some comments, and I'd be happy to hear what you thought to inspire future videos. Thanks.